Namaste students, myself Sunil Kumar from the Department of Computer Science. Today we are moving to the next session based on the chapter Boolean Algebra. In this Boolean Algebra we already discussed in the many sessions. So mainly in this chapter we are getting question from K-map, how to reduce the Boolean expression using the K-map. So here in this case or in this session we are mainly going to discuss about how to reduce all the reducing method we should do. You can group the pairs, or you can do the octet, or whenever if you are going to group the quad, or like that all the methods and overlapping of the group, redundant groups, and also edge mapping and roll mapping, map rolling, all these concepts. These concepts we discussed. So in this session, if you got any Boolean expressions, how to reduce? So in this topic or in this session, we are mainly going to discuss about reducing the Boolean expressions. We are applying all the techniques, which are all the methods we studied for grouping. All the method, any method is required for a particular question that we are going to apply, and then we are going to reduce the Boolean expressions. That thing we are going to discuss in this session mainly. So whenever if you got the question like this, remember this is an important session. In this session we will get the question 5 mark question in the chapter. In the Boolean algebra we are mainly getting the 5 mark questions. That 5 mark question is based on this topic. Based on this topic, we have to reduce from K-map. Using the K-map, we have to reduce the Boolean expression. So I'll explain mainly here 3 examples. So the first example I did here, reduce the Boolean expression. We have to reduce one Boolean expression f of ABCD. F of ABCD is equal to sum of 3, 4, 5, 6, 7, 11, 12, 13 and 15. So this is one question. Using the K-map. By using the K-map, we have to reduce this Boolean expression. When you are going to reduce a Boolean expression, first what you have to see, we have to check whether, I am not going to explain what the steps are required, so I will directly go to the problem because already I explained how to do that one. So first here, if you got the question f of ABCD, so there are 4 variables are there, so we have to construct the 4 variable K-map. So I am going to construct the 4 variable K-map. The first one is here A, B and C and A, B, C and D. Then the values are already you know that one. 0, 0, 0, 1, 1, 1 and 1, 0. Here also 0, 0, 0, 1, 1, 1 and 1, 0. These are the concepts, or these are the values. After writing the value, next step already we discussed and now going to explain more about this one. So next one is C dash, D dash, C dash, D, C, D, C, D dash. So have we got D dash, C dash? That is based on, in case of SOP, whenever the variable value is 0, then the particular variable should be represented in inverted form. At that time, we should represent the variable in inverted form. That is in case of SOP. The next one is A dash, B dash, A dash, B, A, B dash. Same thing here. There are 0, C, D, but here the variable is opposite. That's why I wrote the A dash and B dash. Why A dash we got? A dash means whenever variable value is 0, at that time we should represent the particular variable in the form of inverting. So otherwise normal form. Then we have to number the marks 0, 1, 2, 3, 4, 5, 6 and 7, 8, 9, 10, 11, 12, 13, 14 and 15. So these are the numbers. Cell number means that is a decimal equivalent. Cell number means already explained how to get the cell number. So cell number means what? Cell number is a decimal equivalent. Decimal, any decimal number, any binary number is there, means that binary number decimal equivalent. Here, for you got 0, 1, 0, 1, 0, 1, 0, 1. That is 1, 0, 1, 0, 1. 0, 1, 0 means that is a binary equivalent is, and decimal equivalent is 5. So like that you have to find each binary decimal equivalent, then you have to do. So then that is a method. That is cell numbers. So converting all the binary number into decimal number is difficult. So that's why we are using this method directly writing numbers. After writing the decimal equivalent or after writing the cell numbers, the next step is we have to write the map. Before going to map here, the first variable is 3. First cell number is 3. Go for cell number 3 and mark this one as 1. Cell number 3 is 1. The next one is cell number 4. Go for cell number 4, mark this one as 1. Next one is cell number 5 is 1. Go for cell number 5, mark this one as 1. The next one is cell number 6. Go for cell number 6, mark this one as 1. The next one is cell number 7 is equal. Go for cell number 7. Mark this one as 1. The next go for cell number 11. Go for cell number 11. Here mark this one as 1. Then go for cell number 12. 12 is equal. So we have to go for this one. And after that cell number 13 is equal. Go for 13. And next one is given as 15. Go for cell number 15. Mark this one as 1. So all the cells are marked because which number is given, which terms are given, all the terms we mark here as 0, 1. The remaining terms we should mark as 0, write in white color, remaining terms. After that we have to group. So already told, when you are going to group, first you have to check whether you are getting 8 adjacent cells. Whether 8 adjacent cells are there is not possible here. Then go for, after that is not possible, then go for 4. Then go for 4 adjacent cells. Whether you are getting 4 adjacent cells here? If you are getting 4 adjacent cells, then take 4 adjacent cells here. This one. This row, this column we can mark as a 4 adjacent cells. So this is a one group. One group. Then one more group. So here, you can take this one as one more group. One more group. 2 groups. This main concept is studied. This concept is known as overlapping of groups. If this one is already there with this one, so that also you can do overlapping of groups. Then next one, here only 2 is there. So it's also possible to add with only 2, 12 and 13. 3 is not possible, we should get the 4. So we can add the 4, 5, 12, 13. So it's possible to add 4, 5, 12 and 13. This is the one more group. Because this is already group, this is already group. So we can add these two and we can make it. This is also known as overlapping. So after making the groups, the next step is how to reduce this one. Understood how to make the group? Whenever overlapping is possible, see all the concepts should apply. Pairs possible, octet possible, or quad, then overlapping, edge rolling, map rolling, all the concepts. Whichever concepts are required, all the concepts you have to apply, and based on that concept you have to make the group. Then after making the group, then you have to reduce. How you can reduce? The first one is quad 1. First group, quad 1. You can write 4, 5, 6, 7. 4, 5, 6 and 7. The next group, 3, 7, 15, 11. So quad 2. That will be 3, 7, 11 and 15. So second group. Then after that next group. Next one is quad 3. Quad 3. 4, 5, 12, 13. 4, 5, 12, 13. So we got the 3 groups here. 3 quad groups you got. After getting the group, next if you want you can see this one. I already told in many sessions I explained how to write that one. So I am not going to explain. If you want to doubt with how to write that one, go for previous sessions, see that one. So directly I write here. Directly I write what is the value here? This one is the first 4, 5, 6, 7. 4, 5, 6, 7. Value is A dash B. A dash B is the value for that one. If you go for 3, 7, 11, 15 minutes, that is CD. The next one is quad 3, 4, 5, 12, 13. 4, 5, 4, 5, 12, 13. In that B. And if you take this one, C dash. This is a term. So if you want, you can check with that one, or otherwise you can directly write by this one. It is also possible. So I am not going to explain how to write that one, because that is already we discussed in the many sessions. Almost 4 to 5 sessions we mainly discussed how to write that one. So just if you don't have any doubt, go for previous sessions. We see that one, how to write that one. Best here, see this one, by saying this one you can write. So that's method. So after writing that one, the next step, next you have to reduce the expression you should write. So that is F of A, B, C, D is equal to, the first one is A dash B plus next C D plus B C dash. This is the final expression what we do. See, in first expression there are more than 8 terms are there. More than 8 terms are there. That 8 terms, more than 8 terms, is reduced to only 3 terms. That reduced to only 3 terms. That is a reduced expression. So here is the first example for the reducing a Boolean expression using the K-map. Whenever you are going to reduce a Boolean expressions, apply which and all method you studied. Grouping is very important here. When you are going to group, apply which and all technique you studied. Based on all the techniques you should reduce here. Here is the first example. Let us move to the one more example. Here is the one more example for reducing the Boolean expression using the K-map. See here, first already we discussed one example. Here is the one more example, that is reduce a Boolean expression f of ABCD is equal to sum of 0, 1, 3, 4, 5, 7, 9, 11, 13, 14 and 15. This is the Boolean, this much big Boolean expression we have to reduce by using the K-map. It's the second example. So I am now going to explain how to just different steps. All the different steps are there. First you have to construct the K-map. First you have to construct the skeleton of the K-map. So here the variables are A and B. A and B. Here one more is, this side is C and D. So variables are A and B, C and D. So I will write the values here. I will write C dash D dash, C dash D, C D, C D dash. I am not writing the values. By seeing that you should understand what is the value there. What is the value there? 0, 0, 0, 1, 1, 1 and finally 1, 0. Here A, B. A dash, B dash, A dash, B, A, B and A, B dash. These are the terms. So after writing the terms, I am not going to explain because already I explained many times. So if you have any doubt how to write this one, go for the previous sessions. In previous sessions I explained clearly how to write the numbers. Then after that, next we have to mark the cell number. Cell number means that is the decimal equivalent of a binary number. So here 0, 1, 2, 3, already know, skip the third row and third column, that is better. 4, 5, 6 and 7, 8, 9, 10 and 11, 12, 13, 14 and 15. So these are the cell numbers. That is the decimal equivalent. After writing that one, see the question, and in question which not terms are given, all the terms we should mark as 1 there. So I will go for the terms one by one. The first one is 0. Go for 0 cell and mark that one as 1. The next one is 1. Go for cell number first, mark this one as 1. The next one is cell number 3. Go for cell number 3 and mark this one as 1. Next, go for cell number 4, mark the cell number as 1. Next one is 5 is given, go for 5, mark that as 1. 7 is given, go for 7, mark that as 1. The next one is 9, go for 9 and mark as 1. Next one is 11, so mark this one as 1. Next one is 13, go for 13 and mark that as 1. Go for 14 and mark that as 1. And finally 15, mark this one as 1. Got it. This is simple. All the numbers should take and same number should mark that as 1. After marking that numbers or after marking the particular cells, the next step, next procedure, remaining cells will be there. The remaining cell we should mark as zeros. Remaining cell we have to mark as zeros. 1 and zeros. Then we should go into group the 1. Whenever if you are going to group the 1, first what you want to think? Whether you are getting octet. Then after that, if you are not getting octet, then go for quad. Second option. If you are not getting quad, then go for a pair. So this is the main 3 things. Other than that, whenever overlapping is possible, do that one also. Whenever map rolling is there, do that one. Whenever edge mapping is there, edge rolling is there, that also you can apply. Or sometimes redundant group will be there, that also you can reduce. So these are the different steps will be there. So that we can apply based on the question and based on the mapping, we can apply that one. The first we have to check whether you are getting 8 or octet. Check here. So here 2 rows we can see, 2 columns. See the second column and third column, that is almost full. So it is that is full. Mark as 1. So we can group this one as a single group. So octet we got 1 octet. Octet is over. The next one, 2 is there. We can make it pair. That's possible. 2 is there. We can make it pair. But instead of making the pair, try to add with other and make that quad. So it's possible to make it quad by adding these 2. So normally it's possible to group with only these 2. That's pair. But before going to pair, just check whether you are getting quad. By overlapping method, just check whether you're getting quad or not. Or octet also sometimes octet also possible. Try to get that. So here we got quad. The next only one is there. So 3 is not possible to do. Normally 3 is not possible to do. But adding this one with this, we can make this one as one more quad. Sorry, type. So here what we got here? One octet we got, one quad we got, and also one pair we got. So 3 groups you get. Any other type is not possible to reduce a group. Only anyhow, in which way also if you go to group, we will get the 3 groups. So after getting the 3 groups, next step is reducing. So first one is octet. Octet. The cell numbers are 1, 3, 5, 7, 9, 11, 13 and 15 cell numbers. The next one is one quad we got. So quad 0, 1, 4, 5 quad we got. Next one is pair. Pair we got. That is 14 and 15. So 3 numbers we got after that, or 3 groups we got. After that we have to reduce that one. So directly I am going to reduce. I am not going to see what I reduce. So because already I explained many times how to reduce that one. By seeing that time you should write. So I will write the common term here as a B. Here B is a common term. Then if you take these two, what is the common term? You can only guess. One is A dash, one more is C dash. A dash and C dash is a common term. And finally here pair. These are the common terms. One is A, B, then here C. A, B, C is the common term. After getting the terms, see, remember, here you can see the best example. Whenever octet is there, means only one term will get, only one term. One variable, not term, only one variable. So whenever quad is there, means you get the 2 variables. Whenever pair is there, means you get the 3 variables. That you can understand easily. Octet is there, means only one variable will be there. And if you got the quad, 2 variables will be there. And if you got pair, there are 3 variables are available. So after getting that one, next one is reducing. F of A, B, C, D, that is equal to D plus A dash C plus A, B, C. This is the final expression. So see, this much big expression. Total 11 terms. Mainly we got 11 terms. 8 plus 2 plus 1. So total 11 terms are there. That 11 terms is reduced to only 3 terms. So that much big expression is possible to reduce using the KML. By using KML, that much big term is reduced to smaller term. So here is a second example. So we will move to one more example. That in example we are going to discuss with the 3 variable KML. We are mainly discussing the 3 variable KML. So we will move to the one more example. Here is a third example. In this example, we are taking only the 3 variable. Previous exams we took the 4 variable KML, but here we are mainly discussing with the 3 variable KML. In case of 3 variable KML, only 8 columns are available, 8 cells are available. So, for move to the example, reduce the Boolean expression. How to reduce the Boolean expression? F of A, B, C. So, only 3 variables are there, means 8 cells will output. F of A, B, C is equal to sum of 0, 1, 3, 5, 6, 7. 0, 1, 3, 5, 6, 7. So this is the terms. So what we have to do first? The first we have to draw the structure. We should know the structure of variable or structure of the KML. After writing the structure of the KML, then you write the variables or all the terms you should write down. So after writing the term, then we move to the example here. This example, total 3 variables are there. In that 3 variables, first we have to do means we have to write the KML for 3 variables. So variables are A, B, C, 3 variables. In last case, A, B, C D was there, but only 3 variables. 1 variable here, 2 variables we should draw it. After that one, so your variables are 0, 0, 0, 1, 1, 1, 1, 0. Your variable is 0 and 1. So here easily we can write what is A dash and A. A dash because whenever variable value is 0, should be represented as A dash. Whenever the variable value is 1, they should be represented in normal form. That is in case of SOP. After that, next step. Next we have to here B dash C dash, B dash C, B, C and B, C dash. I'm not going to explain how to write that one because the same concept we discussed with the C and D. Same concept we discussed with the C and D in case of SO. We already discussed the 4 variable. So that is over. After that, next one. Take the example. In example, 3 variable is given. So we have to mark that one. So before that, to mark that one, first we have to give the cell numbers. The cell numbers are, how we give the same cell number? 0, 1, 2, 3, 4, 5, 6 and 7. Total are 8 cells. 0 to 7, total 8 cells are available. After getting 8 cells, you can write that. So after that, next step, see the question. In question is given total numbers. The first one is 0. Go for 0 cell, mark this one as 1. Next one is first. Go for first cell, mark on that one as 1. The next one is 3. Go for third cell, mark this one as 1. Next one is 5. Go for fifth cell, mark this one as 1. The next one is 6. Go for cell number 6, mark this one as 1. And finally 7 is there. Go for 7, cell number 7, mark this one as 1. The remaining cells, what do you have to do? The remaining cells we have to mark as 0. So the 2 cells are remaining, that cell we have to mark as 0. So after that, here we are not getting octet. Octet is not possible in case of 3 variable. Total 8 cells are there. If 8 cells are there, means value will be 0. That expression is not exist. That is leave. But here, how we can write? How we can write this one? When you are going to reduce this one, first you have to check here, not octet. First you have to check whether you are getting quad. Whether quad is available? Yes. Here we can get 1 quad. It's possible to get 1 quad. And after that, this term is remaining, this term. So the 2 terms are remaining. That we can make with the overlapping. Overlapping, this one we can add. This one also we can add with the overlapping. So 2 overlapping groups we got, and also with the 1 quad. 2 pairs and 1 quad. After grouping that one, after you group, just check whether any cells are remaining. All the cells should cover. All the cells which is marked as 1, all the cells should cover. Then only we can go for reducing. So after that we have to reduce. How we can reduce? The first one is quad. Quad. What's the variable? 1, 3, 5, 7. Quad. The next one is pair 1. First pair. Which one will take? This one. So 0 and 1. Next pair. Second pair. Second pair is 7 and 6. So 6 and 7. You take. So 3 terms. So 3 groups we got. So 3 terms. So after reduce, how we can reduce? So we can see that table already. Structure is same. So structure is same. By seeing that we can reduce. So that is method we can use. So I will directly write here. Here A dash is not a common system. This case A dash is there, in this case A will be there. So you can see that one, A dash and A, that's not a common term. B dash B, that's not a common term. But here C is the common term for this group. C is the common term. The next one, here, second one, 0 and 1 if you take it. 0 and 1 if you take it, A dash is a common. A dash is common for this one. B dash, B dash. So B dash also common. C, C dash. C dash, C. That is not a common term. So next one. Next group, this group. If you got the last group here, 6 and 7, A is the common group. A is there. Then next one is B. If you take the C, C dash, that is not a common term. So just by seeing that we can write. By seeing all right code, how to write that one. By seeing this one, we can write the common term. If you are not getting this one, go for previous sessions. I told clearly how to write that one. You can check that one, check that one, and you can write it. After that, we have to write the reduced expression. How you can write the reduced expression? Is equal to f of a, b, c, d. Not a, b, c, d. It's f of a, b, c. Only 3 terms. F of a, b, c is equal to c plus a dash, b dash plus a, b. So this is the expression. This is the expression. So in this mainly we discussed about 3 variables. 3 variables are there. How we can reduce? This question also get for 3 marks. When you have 3 variables in this, they will ask for 3 marks. When you have 4 variables are there, they will ask for 5 marks. In this chapter, mainly you are getting questions from this part, how to reduce. So by here, we reach the end of session today. In this session, we mainly discussed about how to reduce the Boolean expressions using the K-map. And remember, this is very important topic. From this topic, you will get 5 mark or 3 mark questions in final exams. In all the years, you are getting one question. At least one question will be there, 5 mark question, and 3 mark question is there to reduce the Boolean expression using the K-map. So here I will wind up my today's session. Thank you.